Okay, this is going to be our third equation here. This is going to be an equation for velocity as a function of time. And it's going to be linear in time. And we're going to derive it from the equation for acceleration. And so we know that the acceleration, the bar is average acceleration, but we know that we're keeping it constant. So we can actually, if we assume that it's constant, we can get rid of that. So that's going to be constant there, and that's going to be the difference in velocity over the difference in time, or delta V over delta T. And just like the first equation for position and time, delta X over delta T, delta V over delta T is the same, where it's the final velocity minus the initial velocity divided by the final time minus the initial time. And we can view that on the same type of graph, except for we have V of T instead of X of T. So I'll draw that out real quick there. That's V of T, and this is T. We have some arbitrary velocity function there. And actually, we know that the acceleration is constant, so the velocity is actually going to be, we know that it's going to be linear in this case. So here we have, draw this out again, try to keep it fairly straight. Same type of deal. So this is going to be T0, T final. This is going to be V0, which is initial velocity, and final velocity. And so you may notice that we don't need to know the initial position. And if we know the initial, to find the velocity with respect to time, all we need to know is the initial velocity. We don't need to know the initial position. So as before, T0 will go to 0. And I'll go ahead and move that there. So that goes to 0. And we'll strike that out there. T final goes to T as our variable, and V will go to, or V final will go to V. So like that, and I'll go ahead and move these over there too. Just so we can see it clearly. Okay, so that's delta V there. Difference between the velocity as a function of time and initial velocity, and delta T, which is the time elapsed between the time and 0. And so this is our equation here. We do algebra the same way we did before. And since acceleration is constant, we don't have to worry about taking the average. So we take T from the denominator to the other side of the equation, multiply that times the acceleration. And we take the initial velocity from the right side, move it to the left side, switch sides on the equations, and that's our equation 3. And so this is a linear equation for velocity with respect to time, and it's equivalent to equation 1, which is the equation for a linear equation for position with respect to time. And just like we did with x of 0 in the first one, we can actually, if it's going to start off with an initial velocity, we're not going to be able to set that to 0. So that's just going to be our equation 3. All right, great. We'll move on to equation 4. Thank you.